is holding me up right here, so no. Yes, I think that should be us now. 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 That should be us now, definitely. All right, so good night, everyone. Can everyone hear me?
Night, sir.
Night. All right. Next thing, can everyone see me? Can everyone see everything here properly?
Not seeing anything, sir.
Not seeing anything yet, or hold on. Oh yes, let me start this up now. Alright, and then
OBS?
Don't worry about that. Don't worry about that. What you know about OBS, eh? What you know about OBS?
I use it, sir. I used to live stream, sir.
Oh, this is Mr. Justin. Yes, Mr. Justin. What's up, sir? So good night, everyone.
Good, sir.
Alright. So again, can everybody see this now? Can we see this now?
Yes, sir.
Yes? Alright, so let us get going now, people. Let's get going.
Yes, sir. We're seeing.
Alright, so sorry about that, people. Technology just stay how technology always stay. Alright, so technology just stay how technology always stay. Alright, for the persons on YouTube here, remember there's something that allows you to change the quality. So if it does look a little bit blurry or fuzzy, you can change the actual quality. Alright, so you can change the actual quality. Alright, people, so you can send out the link back out here in your school groups everywhere. Where's my phone? Right, send the links out to your school groups and everywhere. Let them know. Oh, it's right here. Whoa. Let them know that we are starting now. Alright, so let them know that we have started now. So sorry about that, but let them know that we are starting now. Alright, so let's get going. Alright, so things to know for all matrices. Alright, so things to know for all matrices. What are the things that we need to know for all matrices? So for all matrices, make sure you know these things. The first thing, make sure you know that rows are horizontal, columns are vertical. The order of a matrix is equal to the number of rows by the number of columns. Even though you might see a multiplication sign there, it's not actually a multiplication sign. It actually represents the word by. Right? So it actually represents the word by.
Did you see what I'm thinking at that?
Sorry, you said, sir?
I think you something right.
Boy, again, I can't hardly hear you. Your mic not going good from last night at all. Let's jump into this first part here, so now. Alright? Let's jump into this first part here, so now. It says, given the matrix below, identify the element in the specified position. So identify the element in the specified position. So can somebody tell me what element is that in the first one? So the first one says row 1, column 3. So row 1, column 3. What do we think is that one?
9.
9. Alright, so row 1, column 3. Row 1 means row 1, and as I said, row means vertical. So row means horizontal. So this is row 1. Column 3 is the third column, so that would be 9. Alright. Next, what about row 3, column 5? So what about row 3,
30.
column 5?
30.
What did you say? How much?
30.
30. Alright. What about row 2, column 4? Row 2, column 4. And what about row 3, column 3.
Y.
Row 3, column 3y. And then the final one, what about row 5, column 6?
So there isn't a row 5.
Alright, so there isn't a row 5. I was trying to catch you with that one, but
You can't catch me that.
so I can't catch you with that one. But I was trying to catch you guys with that one, but alright then, no problem. Alright, let's
Hold on.
continue.
So they
Next.
hear you know or
Yeah, man, I can hear you, man. I'm hearing you. You're not really so great. But
alright.
I can hear you.
So I sent you something private in the chat. I was wondering if you could go back to yesterday's like I could screenshot it and send to my cousin Sarah because she wants
It's
that
probably
class.
because you're not. It has a check chat. Is that okay? Which chat you talking about? You're talking our chat here.
Yeah, in Zoom.
She wasn't here and I can't. So can you go back on the notes on me? So don't worry about that, man. We're going to be running through some notes on the screen here as well. All right. Next, state the order of the matrices below. State the order of the matrices below. Order. How do we find the order? It is
2 by 3.
the number of rows by the number of columns. Alright, so in A, how many rows do we see right there in A? How many rows are there in A? So we see that, and how many columns are there? 3. So what's the order for this? This is called a 2 by 3. So this is a 2 by 3. Let me let you know all of these people, sorry. Next, what about B? What would be the order for that one?
1 by 3.
1 by 3, and again, it's the amount of rows. So remember now, people, and this is very important. The order is very important. So the amount of rows, how many rows are there? Rows are horizontal, 1 row, by how many columns are there? 1, 2, 3, 3 columns. All right. Next, what about M? Sorry, I accidentally jumped out of that. Let's go back in. Page out that here. Alright, so we're at M. What's the order of M? How many rows by how many columns?
1 by 1, sir.
1 by 1, alright, no problem, 1 by 1. And for the persons who are in Zoom, who are online on Zoom, on YouTube, I have my class. This is my actual class here of my students that I am running with in Zoom. So if there's anybody who wants to join, all you got to
2 by 2
people is just to send me a message on WhatsApp. I will pin my number in the chat. Alright, so I'll pin my number in the chat. Alright, so let's get going here now. So some people were asking me about notes. So we're gonna go through all the notes for everything. Obviously, I'm not gonna like sit down here for the whole day and wait for you to write them all down.
So I'm just
Sir, what you said? Oh, sir, what you said, sir?
I'm just screenshotting.
Okay, screenshot it. Yes, so you can screenshot these things, and for the persons who are there who are online on YouTube, you can screenshot this. For anybody who's watching this afterwards, they can always pause it and screenshot it. Very important, right? But what are the rules that we're going to be using here? As it says, so addition, subtraction, scalar multiplication. The first thing, you cannot add or subtract if the orders are not exactly the same. If the orders are not all the same, the answer will be not possible. For scalar multiplication, multiply all the elements on the outside by what is on the inside by what's on the outside. And whenever you have scalar multiplication, always do that first before you add or subtract. Alright, so just look at an example here, then I will give you guys some to try. So the first one says, given the matrices below, simplify the questions given. So, given the matrices below, simplify the questions given. And how do we do this here now? So again, for the persons who might be watching this afterwards, you can always pause, work these things out to give yourself a little trial at it first, and then see if you have the same answers that I have right here. So let's get going here now. So the first thing says 3q. So 3q. In mathematics, if I have something like 3x, 3x means 3 times x, right? If I have something like 3, open bracket, x minus y, what it means is that I have to use this 3 on the outside to multiply everything on the inside. So it's the exact same principle, all right? So the exact same principle. So let's go now. So it says 3q. So 3q, what is q? Q is 7 and 3. And then what do I do to get my answer here? No, I use the 3 on the outside to multiply everything on the inside. So can someone tell me what would we get for the answer for that one right there?
21 and 9.
21 and 9, all right. Thank you, dear Mr. J. R. Mr. Justin, well done. So 21, 9. Next, we have negative 8s. So negative 8s. Again, the principle remains the same. So negative 8s. So that means that we're multiplying negative 8 by whatever the matrix S is. What's the matrix S?
You have negative 88.
Negative 88. Well, no, the matrix S. Negative 11. Negative 11. Don't multiply it.
Oh.
Negative 3.
I worked those, sir.
Negative 2. Negative 5. Next, how you get negative 88 now, sir? A negative times a negative always gives us a what?
Gives you a positive percent. So positive 88.
Alright, so positive 88. Alright. And then what's negative 8
24.
times negative 3? 24. Alright. And then what's negative 8 times negative 2?
16.
And then negative 8 times negative 5? 40.
40.
Alright, no problem. Alright, and as we go on and I give you the questions here, people send them in the chat. Sir, the words are very blurry. The words, which words are you talking? The words on the screen? I don't know. I don't like. Are you watching this on YouTube or are you using Zoom? Because I can see clearly on Zoom. I am here looking on YouTube and I can see clearly on YouTube as well. If you're using YouTube, remember there's a gear button there that allows you to change the resolution of the stream. So you can change it to 1080 because it is supposed to be streaming in 1080. Alright? Well, let's continue here now. Next, we have P plus T plus R. What's the answer for that one? That one should be pretty simple. P plus T plus R. Oh my god, where it gone again? So P plus T plus R. Not sure why this is jumping off. Alright, so here we are. What do we realize about P, T, and R? What do we realize about them? What do we notice?
P and T has the same order, but R has a different order.
So P and T has the exact same order, but R has a different order. And what does that mean?
So
it's not possible.
Subtraction is not possible.
So therefore, addition or subtraction is not possible. And people, this is all you are going to write. There is nothing else that you need to write except for this. And why is it not possible? We already stated that in the notes already. In order for you to be able to add or subtract, the orders have to be exactly the same.
The same.
Right? And even though you might look there and you might say, sir, but the orders of P and T are the same. Yeah, but the order of R is not exactly the same as those. So that's the difference right there. No, the orders of everything have to be exactly the same. All right, let's continue. It says 4t minus 2p. So, are the orders the same? Are the orders the same? T and P, 4t minus 2p, are the orders the same?
Yes, sir.
Yes.
Yes, alright, no problem. So since the orders are the same, what does that mean? Can we add this together or can we subtract them? Can we work them? Yes, alright. But remember here
Got to subtract.
Alright, but before we subtract, what are we gonna have to do, Mr.
Multiply.
So we have to apply the scalar multiplication first. 6, 0, 15. minus 2p, so 2 times, what is p here now? Negative 10. 1, 0, 6, 0, 15. Alright. So what did you say we're supposed to do first, Mr. Justin? Can I just subtract them?
What? No, so you have to multiply. So then you subtract it afterwards.
Alright, no problem. Because remember, it's not called BOM, that's order of operation, but multiplication comes before addition or subtraction. So 4 times negative 10, negative 40, 4 times 1, 4 times 0, 4 times 6, 4 times 0, 4 times 15. Alright. Then minus 2 times all of that now. So 2 times negative 10, 2 times 1.
That's...
Whoa. No, man, it's sitting right there. I the same thing right back over twice. Yeah, sorry about that. What is P? P is actually... so P is actually... So let me get rid of all of this. Alright, so P is actually 1, 2, 3, 4, 5, 6. Yeah, 1, 2, 3, 4, 5, 6. So that's my body right there. So it's 4 multiplied by T. Oh no, I rubbed out the wrong. Oh my god, P finna see me rub out the wrong T. 1, 0, then 6, 0, 1, 5. Alright. Let's try to get rid of these here now. So it's 2 times P. Alright, so, and I'm using a new program. That's why I kind of, not like the other one where I would move so much faster to read that. But by next week I'll get the hang of this program here now. Alright, so I can press this button. I can delete this. Alright, so let's go again. So 2 times 1, that gives me 2, 2 times 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6. Alright, bam. Let us work this out now. Somebody work that out and tell me what's the answer that you're going to get. So work that out, tell me what's the answer that you're getting. And how do we work this out now? Remember, once the orders are the same and you're adding or subtracting, work out the corresponding elements. So let me see somebody in the chat here give me the answer.
Hello. Negative 42, 0, negative 6, 16, negative 10, and 40.
Alright, let's see. So, negative 40 minus 2, negative 42. So remember, it's corresponding elements. That means that goes with this, the 4 goes with the 4, the 0 with the 6, and so forth. 4 minus 4, 0. 0 minus 6, negative 6. Then 24 minus 8, 16. 0 minus 10, negative 10. 60 minus 12, 48. And if we were able to get that answer, well done. Well done right there. So again, remember, we work out the corresponding elements. So this goes with that goes with that, this one would go with that one, this one would go with that one, and so forth. Alright. Based on that, let's do a couple exam ones. So let's do a couple past paper ones. Let's give you the chance to try with this first. Very simple. 2x minus y. If x is equal to negative 2, 0, 5, 1, and y is equal to 4, negative 1, 3, 7, work out 2x minus y. Alright, so 2x minus y. And that's pretty simple. Right, so pretty simple. So again, if x is equal to negative 2, 0, 5, 1, y is equal to 4, negative 1, 3, 7, then see if you can work out 2x minus y. Remember one thing, people, and this is my motto, so for all the persons who don't know me, this is my motto in math. Questions will change, but the principles will always remain the same. And for all the students who I teach, and you know, some of you hear me say that like a million times. I always repeat that over and over again. Because that is just exactly how mathematics goes. So questions change, principles remain exactly the same. What that means is that everything that you just saw us doing for the examples, all of those principles that I showed, that you would have screenshotted, that you could have written down, we are applying all of those same things right now. So not because this is an actual CSEC past paper question doesn't mean that nothing changes. Nothing at all change. Alright, so nothing at all changes. Alright, can I hear some answers as usual? Let me see some answers in the chat. Alright, let's see some answers in the chat. Let's see some answers in the chat. Alright, so let's see some answers in the chat here. So quickly. So 2x minus 1. Okay, Mr. Austin, I see you, sir. See you, Mr. Austin. Anybody else? Okay, I'm seeing a couple more answers here as well here now. Alright, let's work this out. Zero, alright, and I'm seeing some varying answers as well. Nice. So let's go. So 2x plus y. Alright, so 2x plus y. And everything remains the same. So you know 2x simply means 2 multiplied by whatever x is. 0, 5, 1 minus y. What's y? 4, negative 1, 3, 7. And then we need to subtract that there. Alright, so before we can subtract, we need to actually do the multiplication. So 2 times negative 2, negative 4, 2 times 0, 0, 2 times 5, 10, 2 times 1, 2. Minus y, 4, negative 1, 3, 7. So remember here now, people, you have to pay attention to the signs. Don't make the signs kill you. Right? Don't go into the exam and make the signs kill you, because if you have a habit of always disregarding the signs, then oh boy, the exam will give you a problem. Alright? So let's continue here now. So when you're adding or subtracting, work out the corresponding element. So negative 4 minus 4. What does that give to me right there? Bam, negative 8. 0 minus negative 1. That's basically 0 minus negative 1. Remember, these two things you're always going to end up adding when you have two minus signs like that. So 0 plus 1, that is 1. Then next, 10 minus 3, that gives me 7. And then 2 minus 7, that gives me negative 5. Right, 2 minus 7, that gives me negative 5. Let's look and see if there's anybody there with that. I see a couple persons with that answer right there. Alright, a couple persons with that answer right there. Right, let me know if you're understanding that. Because again, here now, when we're finished with this now, you're probably not going to see me doing anything else based on matrices. Still probably the marathon day or so. So please let me know if you're understanding that there. Y is in the chat for a yes. For all of those who understand, who understand this principle, who are able to understand how I get that answer, or who are also able to get that answer. Let's see some Y's in the chat right there from you, please. Some Y's in the chat. Right, some Y's in the chat for all the persons who are good with that. And then let's go again. Next one. Next one. And again, past paper question. Actual past paper question. So 3 matrices Q, R, and S are as follows. So we have Q 2, -1, 4, 3. We have R 1, 6, -5, 4. We have S 2, 7, 4, -1, -8, 9. And when you're calling your matrices, remember you do it row by row. So 2, 7, 4, -1, -8, 9. The first thing they say we're supposed to do, simplify 2R minus 3S. So 2R minus 3S. Part B, using Q and R, show that matrix addition is commutative. So that is something from first form there now. Matrix addition is commutative. That's something from first form. Commutative law. For those who don't remember the commutative law when we're talking about addition, the commutative law says this: x plus y is the same as y plus x. So since it says using Q and R show that matrix addition is commutative, if it's commutative, then that means that Q plus R is supposed to be equal to R plus Q. So that's basically what that question wants you to do, right? Using Q and R, show that matrix addition is commutative. Commutative law states that it does not matter which order. So it don't matter if the Q comes first, it don't matter if the R comes first. When you're adding, doesn't matter which one comes first, the answers should always be exactly the same once it is done properly. Alright, so let us see those who are able to get those answers from right there. Again, answers in the chat as we go on, please. Answers in the chat as we go on as well. Why is in the chat for those who are understanding what's happening here. Miss Campbell, Miss Lawson, Williams, Mr. Duffus, Miss Duffus. Who else is here now? Mr. JD, Mr. Austin, Miss Amelia. Alright everyone, make sure you're putting Y's in the chat so I can see if you are understanding everything here. If there's anything that you want to ask, don't forget, make sure you ask right there. Make sure you ask. Send your answers in the chat as well. Let me see if we have the same answers. Let me see if we have the same answers. Alright, so Mr. Austin, I see you. Mr. Jordan, I see you. But what about the other persons? Right, don't be shy because we're streaming to YouTube here. Remember that the YouTube persons cannot see our chat, so don't worry about that. Alright, so don't be shy. So let's do things how we normally do things. Alright, let's go here now. The first one should be very easy. Very simple. What's the answer for A? Not possible. Alright, ma'am, so not possible. And why is it not possible? Who can tell me why is it not possible? Why? Because the orders are not exactly the same. It's as simple as that, people. So it don't matter if it's a CSEC question, if it's a question you get in a class, it does not matter. Once you add or subtract, the orders have to be exactly the same. If the orders are not exactly the same, then what does that mean? That means that you can't add them together. And once you can't add them together, there's nothing else you need to do than to just write not possible. Next, what did we get for B? Are they commutative? Are they commutative? So basically, are the answers the same? Let's check and see. So Q plus R, 2, -1, 4, 3. Plus R, what's R? 1, 6, -5, 4. Alright. when I work that out now, what do I get? 2 plus 1, 3, negative 1 plus 6, 5, 4 plus negative 5, negative 1, 3 plus that, 7. Alright, let us now check it the other way, r plus q. And remember, commutative means it don't matter which way you switch them round. Any way them switch round, the answer supposed to be exactly the same. Let's go again. So r, 1, 6, negative 5, 4, plus 2, negative 1, 4, and 3. So 2, negative 1, 4, and 3. And we add these together same way like how we added the first two together. So corresponding elements, 1 plus 2, 3, 6 plus negative 1, 5, negative 5 plus 4, negative 1, 4 plus 3, 7. So what would be your answer for this question? Because if them ask you a question like this, you need to write a statement afterwards. So using Q and R show that matrix addition is commutative, therefore matrix addition is commutative.
So sir, that's how you check it then, sir.
That's how we are?
That's how you check it then, sir.
That's how you check it, yeah man. When they talk about commutative, you switch the orders around. So if they gave you multiplication, you can work it out two ways, Q times R and R times Q, right? So that's what commutative means. It does not matter. So commutative, you use two things and it doesn't matter which order. When you're adding, remember say 1 plus 2 is the same as 2 plus 1. 1 times 2 is the same as 2 times 1. But 2 divided by 1 gives me 2, while 1 divided by 2 gives me a half. So what does that mean? Is to say division don't work out the same way. 2 minus 1 give me 1, 1 minus 2 give me negative 1. So again, you see that subtraction either doesn't work the same way. Alright, so subtraction also does not work the same way there. Let's continue. Alright, so going on good so far. Let's continue. Again, for all of you people, for all of my regular students, you're supposed to have all of these things already. Alright. I just basically just wrote down a summary of all the principles. So for anybody who doesn't have these, you can take a screenshot. Anybody watching afterwards, you can just stop the video, take a little screenshot or write these things down. Multiplication is the most important part of matrices. Again, out of all of the operations that you have to know, multiplication is the most important one. Alright, so again, multiplication is the most important one. So what does it say here? Before you can multiply two matrices, you have to do what? Compare the orders. And remember, we already talked about orders already, number of rows, number of columns. Next, when comparing the orders, what does it say? If the inside numbers are exactly the same, you can multiply. If they are not the same, it's impossible to multiply. And if it is impossible to multiply, what would you write for that answer? For any question where you realize that it's impossible to multiply, what do you think the answer would be? What do you think the answer would be? Not possible. Alright, perfect, dear sir. Alright. Next, the second principle. When comparing orders, the two outside numbers will give the order of the answer. And please make sure you keep that in mind, right? So the two inside numbers, the two middle numbers, if they are the same, you can multiply. And then once you realize that you can multiply, the two numbers that are going to be on the outside, they will give you the order of the answer. There are times when CSEC will ask you, what's the order of A, B without multiplying? Right? So there are times where they will give you a multiplication question, give you two things to multiply, but they don't want you actually multiply it. All they want you to do is just to tell them what the order of the answer should be. Next, we only use the rows in the first matrix. We only use the columns of the second matrix. So when multiplying, what do we say? We say row by column. That's how we multiply. row by column. All right. Let's go again. So examples, and then there are some past paper examples for you to track. So some simple examples first. So given the matrices below, simplify the questions given. So given the matrices below, simplify the questions given. So A 2 1 5 3 2 negative 1, B 0 2 5, C negative 5 1 4 negative 2, D 2 0 negative 3 6. All right. So the first one here, AB. And I hope I don't have to explain to anyone that AB means A multiplied by B. Alright, so I hope I don't have to explain to anyone. AB means A multiplied by B. So what do we do here now? So what is A? A 2 1 5, B 3 2 negative 1. So A 2 1 5 3 2 negative 1. What is B? 0 2 5. Alright, so this is totally different from when you're adding or subtracting. When you're adding or subtracting, it is all about the orders. If the orders are the same, right? So if the orders are the same, then you can simply add it or subtract it. So if the orders are the same, you can add it or subtract it. But when that is not the case, alright, so when that is not the case, when you're not adding or subtracting, when you're multiplying, you have to actually check the orders. So you have to physically check the orders. And again, for all the persons who are here in YouTube, don't be afraid to use the chat. Please ask whatever you need to ask. If you want to look back on something, if you want to ask me something, if you want to repeat something, don't be afraid to ask. And the number, the WhatsApp number that has been pinned in the chat, you can WhatsApp me if you want to join our classes. So let's go here now, people. So what's the first thing we're supposed to do? Check the orders. What's the order of A? A is a what? So 2 row, 2 by 1, 2, 3 columns, 2 by 3. What's the order of B? What's the order of B? Again, remember the first number represents the rows. So how many rows? 1, 2, 3. 3 rows by how many columns? 1. That's just one solitary column. Alright. Can I multiply these together? Somebody tell me, can we multiply these together and why?
Yes, we can, because the two inner numbers is the same.
Yes, we can multiply it, and the reason why we can multiply them is because the two what now, sir?
Two inner numbers are the same.
Okay, well, you said 2 inner, it don't matter what you use. You can say 2 middle, you can say 2 inside, it doesn't matter, but we're talking these two numbers right here. Alright, so we're talking these two numbers right here. So you realize both of those numbers are 3. Both of those numbers are exactly the same. And since both of those numbers are exactly the same, what it therefore means is that I can multiply them. So bam, I can multiply them. Next, what would the order of the answer be? So when I multiply these two matrices together, the answer is supposed to be what? What is the answer supposed to be? Remember, the numbers on the outside, so the two numbers on the outside tells you what the order of the answer is supposed to be. So what's the answer supposed to be? A 2 by 1. So what's the answer supposed to be? A 2 by 1. So let's go. Remember, row in the first, column in the second. That's the only directions we go. So horizontally in the first, vertically in the second. Row by column. So 2 times 0. So first number times first number. 2 times 0. 0. Because there are other numbers to multiply by, I'm going to have to do some addition. So 2 times 0, 0. I am now going to multiply by the 1, but I say plus. So 1 times 2, that is 2, plus 5 times 5, that is 25. And again, people, we know the answer is supposed to be a 2 by 1. Remember, a 2 by 1 matrix is a matrix that looks like this. So when you're multiplying, if once you know what the order of the answer is supposed to be, that can also help you to be able to figure out how your answer is supposed to look. I close my bracket. Why am I closing my bracket? Because there are no other columns to multiply by. So I use the row to multiply by the column, but there is no other column, so I close the bracket. Let's go again. Next row now. 3 times 0, 0, plus 2 times 2, 4, plus negative 1 times 5, negative 5. All we got to do now is just to add these together to get my final answer. 0 plus 2 plus 25, that's 27. 0 plus 4 plus negative 5, that's negative 1. That's my first one there. That's how you do basic multiplication. Let's go again. BA this time. BA, you know, so that means that B has to come first. So what is my B? 0, 2, 5. That's my B. So multiplied by, what is my A? 2, 1, 5, 3, 2, negative 1. Can I multiply these two together? Can I multiply these two together? Can I multiply these two together? What do you say? What do you say? What do you say?
Nope.
You say no? Why not? Why not?
But because the two inner numbers are not.
Because the two inner numbers are not exactly the same. And you might be wondering, what inner numbers is he talking about, sir? Alright, let's look. Write down the orders. What's the order of the first one? 1, 2, 3 rows. So it's a 3 by how many columns? 1. 3 by 1. Let's look at the next one. What's the order of this one? 1, 2. So 2 rows by 1, 2, 3, 3 columns. And as we can see right here, the difference between this one and the first one in AB, the two inner numbers are 3. So they are exactly the same. In BA, one of them is 1, one of them is 2. They are not exactly the same. And once they are not exactly the same, that means we cannot multiply. And if I cannot multiply it, what's my answer? Right? So if I cannot multiply, what to be my answer? Once you cannot work these things out and you're doing matrices, your answer is simply not possible. So your answer is simply not possible. Next, DC. So DC. So let's look at D. What is my D? 2036. So I'll do this afterwards. So DC 2036. What is my C? Negative 5, 1, 4, negative 2. Alright. So negative 5, 1, 4, negative 2. Negative 5, 1, 4, 4, negative 2. 4, negative 2. Alright, let's multiply these. Always practice to check the orders. So what's the orders right here? Always practice to check the orders. 2036, that is a 2 by 2. Then negative 5, 1, 4, 2, that's 2 rows, that 2 columns. So 2 by 2 and that 2 by 2. So we have a 2 by 2 and a 2 by 2. The numbers in the middle are exactly the same. That means I can multiply them. What are the numbers on the outside? The numbers on the outside tells me that the answer I'm supposed to get is going to also be a 2 by 2, which means my answer is supposed to look like one of these matrices here. Alright, let's go. Remember, it's always row by column. Never, ever, ever go in this direction in the first one. So in the first one, never go in a vertical direction. Never. That can never work. Alright? In the second one, never go in a horizontal direction. Again, that can never work. Alright? No matter what them give to you, that will never work. Alright, let's go. So, row by column. First number by first number. So we're using the row which is 2, 0. We're multiplying the first column which is -5 and 4. 2 times -5, -10. Because I'm going to multiply by the 0, I'm going to then say add. So plus 0 times 4, 0. So I am done with that column. So we finish with that column. So I use this row to multiply that column. However, in this case, there is another column over here. So I can't just move to the 3 and the 6 before I make sure that I have multiplied all the columns by that row. So I need to use the 2 and the 0 again, but this time I need to multiply by the 1 and the -2. So 2 times 1. 2. So 2 times 1, that is 2. And then, so 2 times 1, that is 2. Why is this thing? Oh, there we go. Alright, so 2 plus 0 times -2, 0. So I have used the 2 and the 0 to multiply all the columns. That's the reason why you see me closing my bracket. Let's go again here now. Different row. So different row this time. So this time now we need to use the 3 and the 6, and we're going to use that row to multiply each column. So 3 times -5, -15, plus 6 times 4, 24. Then 3 times 1, 3, plus 6 times -2, -12. And all we got to do is just to work these things out. Bam! -10 plus 0, -10. 2 plus 0, 2. -15 plus 24, 9. 3 plus -12, -9. So 3 plus -12, -9. And the final question was what? CA. The final question was CA. So what is my C? That's -5, 1, 4, -2. Alright, so CA. -5, 1, 4, -2. Oh no, that is A, sir. That is A, that is A. And we have to make sure that we write the correct ones first, because the order in which you put them will determine. Oh, that's not A, that is C. Jesus. The order in which you put them will determine if you can multiply them or not. So 5, 1, 4, -2, that is C. Then what is my A now? 2, 1, 5, 3, 2, -1. 2, 1, 5, 3, 2, -1. So 2, 1, 5, 3, 2, -1. Alright, so obviously the orders are not exactly the same, but remember, when you're multiplying, the orders don't have to be exactly the same. So let's go. It is row by column, but before we look at row by column, always check the orders first. What's the order of the first one? This is a 2 by 2. Alright, what's the order of the second one? There are 2 rows, there are 3 columns. This is a 2 by 3. Always do this first. These two numbers are exactly the same. That means for a fact that I can multiply. Don't guess. Multiplication is not a guessing thing. Principles will never change. So every single thing that you see me doing here, no, that's the same way that you would approach any question that they give to you. It's just that obviously for CSEC sometimes they try to, they like to give you tricky questions, but the underlying principles are not going to change. So 2 inside numbers, 2 middle numbers, any way you want to say it, those are exactly the same. And then, as I should know by now, once the numbers in the middle are the same, then the ones on the outside will tell me what the order of the final answer is supposed to be. So what does that mean? That means the final answer is supposed to be a 2 by 3 matrix. And remember, when you're multiplying, it's always row by column. So let's go. So row by column. Negative 5 times 2, negative 10, plus 1 times 3, that is 3. Alright, so I am done with that column. Let's now move to the next column, which is 1 and 2, but I am still using the same negative 5 and 1. I'm not ready for the 4 and the negative 2. So negative 5 times 1, negative 5, plus 1 times 2, 2. Alright, then I am finished with that row, with that column, sorry, so I need to move to the next column, still using the same row. So negative 5 times 5, negative 25, plus 1 times negative 1, negative 1. Are there any other columns to use? No, so I am going to close my bracket. Let's go again. Since I have closed my bracket, that means I am finished with the first row. So since I have closed my bracket, I'm finished with the first row. Let's now move to the second row. 4, negative 2. And I'm going to use it to multiply everything just as I did from before. So 4 times 2, 8. Plus negative 2 times 3, negative 6. Then 4 times 1, 4. Plus negative 2 times 2, negative 4. Then 4 times 5, 20. Plus negative 2 times negative 1, that is 2. So again, I use the row to multiply each column. When I multiply it by the first column, I get this. When I multiply it by the second column, I get this. When I multiply it by the third column, I get this. All we got to do now, just to simplify to get our final answer. Negative 10 plus 3, negative 7. Negative 5 plus 2, negative 3. Negative 25 plus negative 1, negative 26. 8 plus negative 6, 2. 4 plus negative 4, 0. 20 plus 2, 22. 22. Was there anybody who was able to get that? Negative 7, negative 3, negative 24. You have negative 24, sir. And then you have 18 instead of 22. 18 instead of 22. Pay attention to the signs, please. Alright, pay attention to the signs, sir. Because you're there, sir. Hype up yourself in the chat and you're not getting 100% right. So can you please do another one like that? Because I don't understand. Like what? Like which one? Like which one, ma'am? Like which one you're talking? You're talking like what I'm doing on the screen now? I don't know if that's what you're talking. If you're talking like what I'm doing on the screen now. Like CA. Oh, so do another one like CA. That's what you're saying? Alright. So somebody wants me to do another one like CE. So let us do another one like CE. Let's see which one of these can work. So BA was not possible. Right? BA was not possible. But if I was supposed to do this, what if I tried AB? Right? So what if I tried AB? Alright, let's look at what my A and my B are. Alright, so A, that is 2, 1, 5, 3, 2, negative 1. Multiplied by B, 0. Oh no, but I already did AB on the screen. What? We already did AB, people. We already did AB. Let me just give 2 random ones. Let me just give some random ones. Let me give 2 random ones. See. So let's just look at 2 random ones. See. Alright, so let's say I have something like this. 7, negative 2, 0, negative 3. And please, people, pay attention to the signs. Let's go again. So this time I'm gonna get, let's use like 1, let's say 1, 4, -3, 6, -5, -2. And please pay attention to the signs. Alright? So we're going to look at some CXC ones next, and we're going to look at some actual past paper ones next. I'll give you some of those next. But let us run back through another one again. First thing, check the orders. What's the order of the first one? This is a 2 by 2. What's the order of the second one? This is a 2 by 3. Once the two numbers in the middle are exactly the same, that means I can multiply. And once I can multiply, then I use this to know what the order of the answer is supposed to be. So the answer is supposed to be a 2 by 3, which is basically like the second matrix. So that means that your answer is supposed to look like the second matrix. Alright? So your answer is supposed to look exactly like how the second matrix looks. Obviously, you're going to have different numbers in there, but it's supposed to look the same. Let's go. Remember now, row by column. So we only move horizontally in the first one. We only move like this in the second one, and that's just the key to know. The principles never change, so that will never change. So let's go. So 7 times, so first number times the first number. 7 times 1, 7. I still have another number to use, so I say plus second number by second number. So remember, we're going this direction, so the first number is 7 and the second number must be -2. Remember, we're going in this direction. Alright, we're going in this direction here. For the second one, we're moving in a vertical direction. So since we're moving in a vertical direction, that means the first number have to be 1, and then the second number this time would be 4. So just keep that in mind. So 7 times 1, first times first, 7. Second number times second number, -2 times 4, -8. So we're finished with that column. Let's move to the next column now. So we just use this column right here. So we now need to move on to the next column. So the -3 and the 6. We're still using the same 7 and -2. First number times first number. 7 times -3, -21. Next, second number by second number. Right? So -2 times 6, that is -12. Then let's go again, row by column. So row by column. 7 times -5, -35. Plus second number by second number, -2 times -2, 4. Close my brackets because I don't have any other. There are no more matrices, no more columns, sorry, to multiply the 7 and the -2 by. Now let us move to the next one. So the 0 and the -3. Same procedure. First number by first number. 0 times 1, 0. Plus second number by second number. -3 times 4, -12. Let's go again. First number by first number. 0 times -3, 0. Plus, let's go again. Second number by second number. -3 times 6, -18. Then let's go again. Same 0, -3 by the final column. 0 times -5. First number times first number, plus second number times second number. -3 times -2. That gives me 6. And then all we got to do now is just to add all of these things together. So, so add all of these things together. So 7 plus -8. So 7 plus -8. Where is it gone? So 7 plus -8, that gives me -1. Gives me -1. Why is this not coming off the screen? Why is this not coming off? Why is this not coming off? I have no idea why that's not coming off the screen. I'm not even worried about that. Alright, 7 plus -8, -1. -21 plus -12, that gives me -33. -35 plus 4, -31. 0 plus -12, -12. 0 plus -18, -18. 0 plus 6, that is 6. That will be my answers for all of these. That will be my answer for that question right there. Right, so that will be my answer for that question right there. Whoa. This is stuck here. Definitely is. Alright, next. I don't know why this thing is freezing a bit, but anyways. So let's continue right there. So exam questions now. The first one, pretty simple. So what is TG? So what is TG? So what is TG?
I can see the answer aloud or read.
Oh, I can't wait. Send it in the chat. Send it in our chat. All right, let's go. So, TG, so if they give us TG, you know what that means? That means T comes first, followed by G. Alright, so T comes first, followed by G. So what is my T2312? What is my G? -23.
33 T is negative.
Okay, thank you, ma'am. Thank you. What's the order of the first one? 2 by 2. What's the order of this one? 2 by 1. These two things are exactly the same. That means the answer is going to be a 2 by 1. Like, I don't know where that black thing comes from and it's not even coming up. So let's see here. So first number by first number, remember it's only rows in the first, it's only columns in the second. First number by first number, 2 times negative 2. What does that give to me? That gives me negative 4 plus second number by second number, negative 3 times 3, that's negative 9. Then next row, 1 times negative 2, first number by first number, plus 2 times 3, 6, second number by second number. Negative 4 times negative 19, negative 13, negative 2 plus 6, that is positive 4. Let's go again. Next, this one is a little bit more, so you need a little bit more time to try this one. Explain why the matrix product QS is not possible. So that's the first thing there. Can you tell us why QS would not be possible? Then state the order of the matrix product SR. You realize the question never asks if you multiply S and R. No. It's safe if you just state the order, which is what I told you. There are times where they can give you a multiplication question where they don't even want you to multiply anything. What they want you to do is to just figure out what the order of the answer will be. And in part 3, calculate the matrix product QR. So the first one, explain why QS is not possible. And let's see if you can do that. I already told you how to figure out when it is possible. And then state the order of the matrix product SR. And then the final one in that set of questions, calculate the matrix product QR. So again, the second question, you don't need to actually multiply it. All they want you to do is to figure out what the order will be. The third question, you are supposed to actually multiply it and figure out what the answer is. I got no idea. So 3 matrices Q, R, and S. Alright, so 3 matrices Q, R, and S. Oh, what just happened? Because the inside numbers are not the same. Alright, you can't really say that still, you know. Like, obviously that's the way how I showed you that you'll be able to figure it out. But if they ask you a question like that, you can't tell them because the inside numbers are the same. Alright? So you cannot tell them because the inside numbers are exactly the same. It is different. Alright? So it will be different. Alright, let us get going. Alright, first one. Explain why the product QS is not possible. Alright, so for Q, the order is at hold on, let me pin myself again. Alright, there we are. Alright, so I was wondering why it was moving a little bit weirdish. I was wondering why, yeah, because the internet was acting. Alright, so Mr. Austin, even though you are not really wrong, based on what CSEC wants, I'm not going to tell you say you're not really right. Alright, so that's the reason why it is not possible. Because the columns of matrix 1 are not equal to the number of rows of matrix 2. Remember this, you know, it is row by column. So that means that this 2 right here represent the column of matrix 1. It is row by column. That means that this 3 represent the amount of rows in matrix 2. So the number of columns in matrix 1 is not equal to the number of rows in matrix 2. Alright, next. The next thing that this question says, they don't ask you to multiply it, you know. All they said is state the order of the matrix product SR. Right, so state the order of SR. What does that mean? That means all I got to do is to tell them what the order is supposed to be, or what the order is going to be. So what's the order of S? SR means I start with S first. S is a 3 row by 2 column matrix. 1, 2, 3, 3 row, 2 columns. R is a 2 row by 2 column matrix. So this is a 2 by 2. 2 numbers in the middle are exactly the same. The answer will have the order of the numbers on the outside. Therefore, the order is going to be a 3 by 2. Now you see that I got the answer for that without having to actually even multiply. No. Never have to multiply, nothing at all to get the answer for that one. So never had to multiply anything. The third one now, calculate the matrix product QR. Alright, so this one here now, QR. Alright, so QR, Q, 2, negative 1, 4, 3. So 4, 3. R, 1, 6, negative 5, 4. Remember, product means to multiply. So when they say what's the matrix product QR, they simply want us to multiply them together. That's a 2 by 2 and a 2 by 2. That means they can be multiplied together. Let's go. Rows in the first, columns in the second. First number by first number, 2 times 1, 2, plus the second number by the second number, negative 1 times negative 5, 5. Then let's go, next column now. First number by first number, 2 times 6, 12, plus second number by second number, negative 1 times 4, negative 4. Then let's go again, next row now. So 4 times 1, first by first, 4 times 1, 4, plus second by second, 3 times negative 5, negative 15. Then next, that same row again, first by first, 4, 6 is 24, plus second by second, 3, 4 is 12. So when I work that out, 2 plus 5, 7, 12 plus negative 4, 8, 4 plus 50, negative 15, negative 11, 24 plus 12, 36, not 26, sir, 36. 36. All right. Let's go again. So, on the right track, moving nice, moving nice, moving nice. So we have completed everything up to multiplication so far. Bam, let's move on. That's finally off the screen. So after multiplication, we now have what we call equal matrices. So equal matrices, what are equal matrices? As it says, when two matrices are equal, they must have the exact same orders. That's the first thing. The second thing, the corresponding elements will be equal to each other. right? So the corresponding elements will be equal to each other. And then the third thing, corresponding elements are elements in the same position in different matrices. And we're talking about corresponding elements, we're basically talking about like when you're adding. Remember when you add or subtract, you have to add or subtract the corresponding elements. So that's basically what we're talking about right there. Alright. So when two matrices are equal, must have the same orders, corresponding elements will be equal to each other, and the corresponding elements are the ones that are in the same position, but they are just in different matrices. Alright, so just in different matrices. And again, for the persons online here, I see a couple messages on WhatsApp saying that you are here from YouTube, blah 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 blah. There's a link to join the Zoom session. Okay. Alright, and as well, if you're in YouTube and you think you would actually want to join the actual Zoom session, you can send me a message and I will shut you the Zoom session for tonight. I read the question wrong. They want specifics. Yes, sir. They wanted specifics. Alright, let's move on. Now, next. So, again, remember, when they are equal, they must have the same orders. The corresponding elements will be equal to each other. Corresponding elements are elements in the same position in different matrices. So, what does it say? Given A equals what is equal to B equals that, C equals that, find A, B, C, and X given 2A minus 3B is equal to C. So 2A minus 3B is equal to C. You realize that in C you have A, B, C, then negative 9. In B you see negative 5, 7, 6, X. And then no found in all start say, boy, sir, I can't do this, sir, I can't do this because I see letters in it and I never yet get a question with letter in it and I don't know how to do it with letter and blah blah blah, all sort of things. Instead of just understanding and remembering what I always say, principles will never change. Alright? So no matter what, always remember that principles will never change. So the first question, well, not the first question, they want us to find the variables given 2A minus 3B equals C. So basically we have some equal matrices working with here. So what you do is that you work out everything on the left hand side, work out everything on the right hand side if there's anything to work out over there, and then the two answers are going to have the same orders. Then once the orders are the same, you just make the corresponding elements equal. So let's go. So 2A, 6, 1, that's 6, right? Negative 4 and 3, so that's 7. 6, 7, negative 4, 3. And B, 3 times negative 5, 7, 6, X. So negative 5, 7, 6, and X. Alright. So remember, work out the multiplication part first. So 2 times 6, that's 12, that's 14, that's negative 8, that's 6, minus 3 times negative 5, so that's negative 15, 3 times that 21, that's 18, and then that is 3x. That's the left hand side. And they say once I work out that it's going to be equal to C. And what is C? A, B, C, negative 9. Right? So A, B, C, negative 9. Work out the left hand side. Let me give you a 15 seconds or so. Work out the left hand side. Hello, ma'am. Did you see the link? I just... Sorry, what you said? Wow, oh my god. So unfortunate, huh? Anyways, but at least you got it, so, huh? Yeah, I know, but I'm saying you can interact more if you're in the Zoom. So once it's updated, you can jump on where you can ask questions in the chat and you can hear the other students talking to you. Because you can't hear the other, you're not able to hear the other students, right? Or you can hear what they're saying. Alright, no problem. But anyways, I got to get back here now. Bye-bye. Alright, let's get going now, my people. So what did we get for that one? Okay. Let's see. Seeing some answers in the chat. They're looking very interesting. So 12 minus negative 15. Pay attention to the signs. Again, 12 minus negative 15. Let me zoom in. Make sure you're seeing this. Let me zoom in. So it's a 12 right here, minus, and this is negative 15. 12 minus negative 15, 12 plus 15, 27. Alright. 14 minus 21, negative 7. Negative 8 minus 18, negative 26. 6 minus 3x. Don't tell me 3x. Don't tell me negative 3x. Do not do what you never learned, because I'm 100% sure none of you guys never learned that before. Alright? So 6 minus 3x is 6 minus 3x. Remember, if the letters are not the same, the answer just remains the same. So if I give you something like x plus 1, it's the same as x plus 1. It's not 1x. If I give you 3 minus b, it's the same as 3 minus b. If the letters are not all exactly the same, then you cannot work it out. Alright? So this is equal to here now. What is this now equal to? A, b, c, negative 9. Alright. What is a equal to? What's a equal to? Anybody here? Mr. Austin, right? Mr. Duffus, Miss Campbell, Miss Amelia, anyone? Yeah, but what is a equal to? There is where we read so far. What would a equal to? 27. Right, so there's not, you don't need to do nothing else because I've already worked it all out. You just need to look there now. So I worked out the left hand side, I got this. This is the right hand side. They are equal to each other. So all we do now is to do this. Corresponding elements are equal. That means A equals 27. Can somebody tell me what would B be equal to? So what would the variable B be equal to? Anybody again? Anyone of you guys?
Negative 7.
Negative 7, alright. And good night, Miss Mitch. Thank you for joining us here from YouTube, ma'am. You can get yourself involved. C is obviously negative 26. And let me see if anybody can figure out X. Let me see if anybody can figure out X. Let me see if anybody will send me the correct answer for X in the chat. So X. You say negative 5. Is there anybody else who also thinks it's negative 5? And then no, you must switch your mode fast. Switch your mode fast, go to positive 5, sir. Alright. But remember, you always have to pay attention to what you're doing there. Pay attention to the signs, some please. Alright, so we always got to pay attention to the signs. Alright. So let's go. This is gonna give me 6 minus 3x equals, what's that equal to? That's equal to negative 9. Remember, you want to find the value of x. It's the same thing when you used to, which means we simply going to solve the equation. So negative 3x equals -9 minus 6. And by the way, people, if you can't solve an equation, you won't be able to pass the exam. Right? So the equation doesn't just, solving an equation does not just come in a question that talks specifically about equations. As you can see right here, we are doing matrices, but yet still we end up having to solve an equation. So what's my answer? X is equal to positive 5. So x is equal to positive 5. So again here now. So what did we do? The first thing, work out the left hand side. So it says 2a minus 3b. That's my 2a, that's my 3b. Work that all out. Once I work that out, I then make it equal to c. Right? I then make it equal to c. There you see it being equal to c. And then once you work it out and both of them are equal, then my answer is c. My answers are corresponding. So 27 is a, -7 is b, -26 is c, and then this gives me -9. And that's how we work out any question at all like that based on equal matrices. Alright, equal matrices. Let's go again. And you can see how I've been doing this all night. I start with some notes first, give you a chance to screenshot it or for the persons who don't get these things. Because I know a lot of you guys don't seem to get good notes in school, or when I'm not writing the notes because I'm too lazy. Right? But I make sure that I show you the notes, then we run through some examples, then I give you a few actual past paper ones to try. Try this one from here now. Even you a minute, try this one here, try this one here, try this one here. So well, let us do the first part together, the AB part. So let us do the multiplication part together. And then you can try question B on your own. So question A wants me to multiply. It's A times B. So A, 3, 5, 1, 0 times B. What's B here? 6, 4, -1, -2. Same multiplications that we have been doing. Alright, so same multiplications that we have been doing. So let's go. So remember, row by column. So 3 times 6. So first number by first number, 18, plus second number by second number, 5 times -1, -5. Then let's go again, row by column. Next column now. First by first, 3 4s 12, plus 5 times -2, -10. Alright. So, row by column again. First by first, 1 times 6, plus 0 times -1. Then row by column again. 1 times 4, plus 0 times -2, that gives me -2. To get my final answer, I simply add those all together. 18 plus -5, 13. 12 plus -10, 2. 6 plus 0, 6. 4 plus -2, that gives me 2. That's the first part of the question. You're using that part of the question to answer part B. So you're using that part to answer part B. So, calculate the matrix product AB. We have done that already. Next, we now need to work out if C is equal to X, -8, 4y, right? And 2a plus C equal. Right. So, 6, 10, 2, 0. Then plus x -8 4y. Alright, so this is not acting good at all. Can somebody explain to me why flow no want to be great? Huh? Why does flow not want us to be great? X is equal to 7. Alright, somebody says x is equal to 7. What's your answer for y, ma'am? So somebody says x is equal to 7. That doesn't look. Just switch to Digicel. Alright, people. Now I'm gonna try to. Hey, oh no promotion here. Digicel have to pay me. Digicel have to pay me to come promote them right here, right now, you know. But on a serious note, for some reason I don't know why this Flow internet is always giving us an issue. Flow, if you all watch me, yes, I want to make a chat about. We need to do something about in the internet. Let's get going here now. So 6 plus x is 6 plus x. Then 10 plus negative 8, that is 2. Alright, hold on. Alright, so 10 plus negative 8, that is 2. Then 2 plus 4, that is 6. 0 plus y, that is y. Alright, so 0 plus y, that is y. Remember here now, corresponding elements are equal. So corresponding elements are equal. So I'm supposed to make that equal to AB. What is AB? 13. 2, 6, 2. And I want you guys to realize something. Look at the corresponding elements and realize these are exactly the same. Look at the corresponding elements and realize these are exactly the same. So what is that going to mean about, what does that mean about this? That means that these are also exactly the same. Right? So that means that these are also exactly the same. Again, in order for you to answer these questions, you have to be able, if you can solve an equation. If you can't solve an equation, boy, I don't know what to say to you. You won't be able to pass the exam. So x is equal to 13. And then when I transpose the 6, it becomes minus 6. X is equal to 7. And y is pretty simple, right? Bam, 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 bam. These are corresponding elements. That means y is simply equal to 2. Well done there, ma'am, for the lady who sent that in the chat to me. X is 7, y is 2. Perfect, 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 perfect. 2. Let's get going. Still got a few more things to do. Alright, so we're now in the nitty-gritty section 2 now. So section 2. So section 1, we just look on some of the most basic things there. Addition, subtraction, scalar, multiplication, equal matrices. Section 2, this is where the majority of the questions come from. Alright, so this is where the majority of the questions come from. You cannot go into the exam and not know how to find the inverse of a matrix. Let me repeat. You cannot go into the exam, right, and not know how to find the inverse of a matrix. So here I have some information. So we're looking at the determinant, the adjoint, and the inverse first. So you're going to hear about something called leading diagonal. What's the leading diagonal? Just know we're talking about the top left to the bottom right. And we will explain that as we look at questions. You're also going to hear about the non-leading diagonal. What's the non-leading diagonal? All you need to know is just top right to bottom left. Remember, diagonal is something like this, right? So top left to bottom right, top right to bottom left, right? When we're talking about the determinant of any 2 by 2 matrix, as it says here, it's the product of the leading minus the product of the non-leading. When we're talking about the adjoint of any 2 by 2 matrix, what do? Interchange the leading diagonal and change signs of the non-leading diagonal. And again, these are all things that I would have actually taught in detail in my Zoom online classes. Right, but so we're just trying to just run through as much of this as we can, but I'm just running back through it again. Inverse of any 2 by 2 matrix, what do? Combine the determinant and adjoint using this formula. Here's the formula here. A with the negative 1 above, what does that represent? That represents the inverse of A. A with the two little bars beside it is representing the determinant of A. Alright? So again, A with the negative 1 means the inverse of A, and A with the 2 bars beside it is representing the determinant of A. And C tier, to find the determinant, product of leading minus product of non-leading. To find the inverse, we just use that formula right there. And take your screenshot if you need to. Take your screenshot there if you need to, or take your picture there so if you need to. Let's continue. Next example. So given A equals negative 7, negative 4, 3, 6, find, the first question says A adjoint. Question B, what does that symbol mean? That represents the determinant. And then question C, what does that symbol mean? It represents the inverse. So what does that mean? We just have to know what our different symbols mean. So when we see them, we know exactly what they want us to find. Exactly what they want us to find. So A, adjoint. As it says, to get the adjoint, you interchange the leading diagonal top left to bottom right. So you interchange those. So negative 6 comes right here, negative 7 comes right here. You change the signs of the non-leading diagonal. Non-leading diagonal, what's a non-leading diagonal? That's this one right here. We're going to change the signs. So negative 4 becomes positive, 3 becomes negative. That's my adjoint right there. Question B. We now want to find the determinant. Right? But remember now, how do we find determinant? It's product of leading minus product of non-leading. And we have already talked about what the leading is, what the non-leading is. Alright, so we have already established what the leading and what the non-leading is. Right, so what is the leading? Those are the ones in red. So negative 7 times negative 6, 42. Minus, what's the non-leading? Those are the ones connected by purple. Negative 4 times 3, negative 12. Remember here now, when you have two minus signs, you have to add them. So I get negative 7 times negative 6, that's how I get the positive 42 minus, the minus is always there. And then negative 4 times 3, that is negative 12. That's why I'm going to end up having to add. And 42 plus 12, that's going to give me 54. Part C now I need to find the inverse. So if it's A inverse, it's 1 over the determinant, and you simply multiply that by the adjoint. So once they want the inverse, you have to find the determinant, you have to find the adjoint first. That's a must. Alright? So you have to find the determinant and you have to find the adjoint first. That's a must. Why this internet is acting up. So I have to find the determinant, have to find the adjoint first. What's my final answer here now? So 1 over, what's my determinant? 54 multiplied by, now we don't have to use the actual multiplication symbol, we can just combine them. What's the adjoint? Negative 6, 4, negative 3, negative 7. That's my inverse right here. I know a lot of teachers have this habit. A lot of teachers have this habit of telling you that, oh no, you have to multiply what's on the inside by the fraction on the outside. CSEC does not matter. Right? So CSEC really and truly doesn't matter about that. Right? They really don't matter about that. So when you're working this out, if you leave your answer just like that with, right? So if you leave your answer like that with the fraction on the outside, you're perfectly correct. They are not going to mark you down for that. The only time they would mark you down is if they specifically ask you to multiply it by what's on the outside. But they will, I think there's only one time I've ever seen them ask to actually multiply. So to actually use the fraction on the outside to multiply the inside. Alright, let's go again. Next question. If P is equal to 1, -1, 3, 2, find P inverse. So if P is equal to 1, -1, 3, 2, find P inverse. And remember here now, P inverse, you're using the same formula. It's just an inverse, so you have to find, so you're using the same formula there. In order for you to find the inverse, you have to find the determinant, and I see somebody explaining that in the chat, alright? So you have to find the determinant. After you do that, you have to find the adjoint, and then you combine them. So don't forget that it's not just about the determinant, you have to find the adjoint. So you have to interchange what you need to interchange. You need to change the signs of whatever you need to change the signs of. Somebody sent me an answer, but you forgot about the adjoint. Want your adjoint. Right? Yeah, I see you have got the exact same thing as P. Want your adjoint. Alright, so what about your adjoint? So let's go. So you want the inverse, the first thing you have to do, find your determinant. So what's my determinant now? Product of leading. So 1 times 2, 2, minus. So minus product of non-determinant. And I multiply that by my adjoint. So what's my determinant? That's 5. So 1/5. And boy, people, I'm fighting some very bad internet right now. Right? It's very bad internet. My gosh. So 1/5, and then the adjoint here, 2, 1, -3, and 1. So 2, 1, -3, and 1. So again, find the determinant first, find the adjoint, and then to get the inverse, you simply just combine them together. Inverse, combine them together. Alright, next. Solving simultaneous equations, and this is the final thing. Right, so this is the final. This is like the final boss, right? So in a normal matrices, and you have not abnormal, but you have a different type of matrices called transformation matrix. Right? So there's a different type of matrices known as transformation matrix. Right? It's a transformation matrix. When you do that type of matrix, that's like equal to B. Oh my God. People can't tell flow, so they need for the something about them internet. My God, man, my program uses the internet and these people are killing me. These people are killing me here.
So you know that it's actually your fault.
How can that be my fault, huh?
Because we have been telling you to switch for a very long time, and you do not want to switch.
No, because I already have flow, so I'm like, alright, cool.
And you know how flow is.
Yeah, it definitely basically look like they're forcing me to change tonight. Change it up tonight or something, cause no man, I can't do this every week. Can't do this every week. Alright, let's go again. Alright, so solving the simultaneous equations, as I said. So the first thing, write the equations in matrix form. Right, so write the equations in matrix form. What is matrix form? As you can see right there, it says AX equals to B. That is what we call matrix form. AX equals to B. Alright, switch up on them, sir. So AX equals B. What does A represent? A represents the coefficients, and you're doing a CSEC exam for all of my CSEC students here. That means by now, the fact that coefficients and variables is something you learn in a first form, you're supposed to understand what we mean when we say A is the coefficient. So you're supposed to know exactly what those are. Next, it says X. X represents the variables. Again, that's another thing right here now. Alright, so that's another thing right here now. Remember, you're in fifth form, so you're supposed to understand what I mean by variables. But remember that variables are simply the letters. Alright, so they're simply the letters. That's the first thing. The second thing you do after you write it in matrix form, find the inverse of A. Remember, the inverse of A is A with that negative one at the top. After you have found the inverse of A, then the final thing that you do, the third and final thing, find the values of X and Y using this formula. So what's the formula? X equals A inverse multiplied by B. And again, this is the final boss, right? So final boss. So this is the final thing that we want to look at tonight, based on simultaneous. Based on matrices. So it says solve the following using a matrix method. So solve the following using a matrix method. First thing, what do we do first? And that's the first thing that you will always do. Write the matrix, write the equations in matrix form. Matrix form means this. So matrix form means I am going to be left with AX is equal to B. Right, so AX is equal to B. So AX is equal to B. What is A? A represents the coefficients. Again, you're in fifth form, so you're supposed to know the coefficients are the numbers that are attached to the variables, the letters there. So if I want the coefficients, then that means I have 2, that's the coefficient of X there. Negative 3, that's the coefficient of that first Y. Negative 3 right here, that's the coefficient of the second X. And then 8, that's the coefficient of my second Y. Then X, the matrix X represents the variables. Those are the letters. The two letters are X and Y. Put in the X at the top, put in the Y below, and then this now is equal to B. What is B? B are the answers. So that's 7 and that's negative 7. Next, AX equals B. We have done that. The next thing that you do now is to find the inverse of whatever the A is. So now I need to figure out A inverse. Right? So now I need to figure out A inverse. And remember now, it's the same formula that we would have been using when we were looking at the actual inverse. So what's the formula for inverse? It's 1 over the determinant. Remember, that's how we write determinant. So that's 1 over the determinant. And then you multiply that by the adjoint. And then you multiply that by our adjoint. So the determinant, starting with that one first, the determinant is equal to the product of the leading 2 times 8, 16, minus the product of the non-leading negative 3 times negative 3, that's 9. So therefore, what does that mean? That means that my determinant is 7. So my determinant is 7. Next, adjoint now. So adjoint now. And boy, this internet is doing me bad. Like it's even making the things kind of stuck. Alright, but let's continue. So adjoint here now. So switch that around. So interchange the ones in the leading diagonal. That means 8 is going to be coming right here. And in the space where the 8 is, 2 is going to come right here. Then change the signs of the non-leading diagonal. So negative 3 becomes positive. And then this other negative 3 also becomes positive. So that's my adjoint. So therefore, what's my inverse here now? So therefore, the inverse equals 1 over 7. And I multiply this by my adjoint 8, 3, 3, 2. So 8, 3, 3, 2. That's the inverse. So step 1, write it in matrix form, and yes, people, is going to be a little bit long like what you see there. Step 2, find the inverse of matrix A. That's the inverse of matrix A. Step 3 is to basically work it out now, but you're going to work it out using a special formula. And what is that special formula there? That special formula, X is equal to A inverse. So it's not A times B, people. Don't mix it up as A times B. It's A inverse, and you multiply A inverse by B. So write it in matrix form. Once you have written it in matrix form, then what do you do next? Alright, so write it in matrix form. Then once you have written it in matrix form, you find your inverse. So find the inverse. Once you have found the inverse, then you can now work it out using the formula that you see right here. Alright, so what is X? X actually represents the matrix X, Y. So that's the matrix that contains the 2 variables, the 2 letters in question. Next, it's now A inverse. What is A inverse? So what is A inverse? 1 over 7. Again, people, boy, the internet is really moving mad. The internet is moving mad, boy. So the inverse right here, 1 over 7. And I multiply that by B. What's B? That's 8, 3, 3, 2. No, sorry, that's not. Whoa, what am I talking about? That is A inverse. All of that is A inverse. Now I multiply it by B. Jeez. What am I talking about? All of that. So now I multiply it by B. What is B? B are the 2 answers. And what are those 2 answers? 7 and negative 7. So 7 and negative 7. Alright, people, you should know how to multiply now, because we have done work based on multiplication. Right? So you should know how to multiply now. So xy equals, when you're multiplying, leave the fraction for last. Right? So when you're multiplying, just leave the fraction for last. So 1 over 7, we're just going to write back that 1 over 7. We're not ready to use that yet. I'm going to multiply that by whatever I get when I work out A inverse and B. So whenever I work out those two matrices, whatever I get, I'm going to multiply that by 1/7. So row by column. So first times first, 8 times 7, 56, plus second times second, 3 times -7, -21. Next, same thing again, row by column. First times first, 3 sevens, 21, plus second by second, 2 times -7, -14. Alright, so x, y equals 1/7 of, alright, so what do we get when we work these different things out here now? 56 plus -21, that's 35. 21 plus -14, that's 7. Still not finished yet. And yes, people, it is long. It is a bit long. And you have to try to remember all of the steps then. Alright, it is a bit long and you got to try to remember all of the steps then here. So what do I do here now? When you're multiplying that by the fraction, basically just divide by the denominator. So 35 divided by 7, that is 5. 1/7 of 35 is 5. 7 divided by 7, that is 1. 1/7 of 7 is 1. Right? Before we finalize anything, we're going to do this. This is a check. Whenever you're doing these simultaneous equations, practice to put a check on the paper. So practice to put that section on the paper right there. As I always tell my students, when the examiners look at your paper, if they see that for questions like these, you're always writing the check and you're always checking them, making their work easier basically, then these are the students that they pick out to give their mathematics prizes to. Alright, so let's go here now. So x is 5, y is 1. So x is 5 and y is 1. And what is it there? It is 2x minus, let me leave it up here. So 2x minus 3y. X is 5, y is 1. So 2 times 5, 10. 10 minus 3 times 1 is 3. 10 minus 3, that does give me 7. And that is correct. Next, so x is 5. So -3 times 5 is -15. Plus y is 1. 8 times 1 is 8. -15 plus 8, that gives me -7. So that is perfectly correct. And that's the way how we solve these things using matrices. Again, yes, people, I know it does look a bit long. Right, if I zoom out to try to show everything, it does look long, yes, because it starts from all the way right there. So it is going to be a good amount of working out, but that's where your practicing comes in. Once you have practiced enough, then you will be able to remember what you're supposed to do. After I have checked, I realize both answers are exactly the same, so I can now write my final statement. So therefore, x equals 5 and y equals 1. Right. And as usual, you know what's going to come now. So you should know what's going to come now. So I just gave you some notes to write down based on that, and we did an example. So again, you should know what's coming now, and that means you should know that you're going to have one to do on your own, or have a couple to do on your own. Exam questions again. This time question 7. If A is 3, 2, 2, negative 3, the first one says determine the, evaluate the determinant of A. Then the second one says determine A inverse. Then the third part says using A inverse, solve the simultaneous equations. Right? So using A inverse, solve the simultaneous equations. Sorry about that, people. We're on the final trick here now. I know sir always have classes before, so like I've been in class from like what time? From like 2 o'clock. So let's see if anybody can get that answer. Remember, you can check your answer. That is the only way, not the only way. That is how you can know for a fact, right? So that's how you know for a fact that yes, my answers are correct. I don't need sir to actually tell me that my answers are correct, right? So I don't need sir to actually tell me. Once I check it and I realize that I am getting back the same numbers that are in the answer, then again, you don't need anybody to confirm that for you. And as usual, please send your answers in the chat. So you're finished. I see people in the chat telling me that it has been over a year that I have been having internet issues. People, come on, man. So I only can remember all of that, and I don't remember some of the maths. I only can remember that sir has been having internet problems from last year, but we can't remember some of the maths. All right. Anybody has gotten X and Y here now? I'm going to work this out. So the first one. The first thing, determine the determinant of A. So you know determinant of A. Those are my 2 bars. So those are my 2 bars. Product of leading. 3 times negative 3, that's negative 9. Minus product of non-leading. 2 times 2, that's 4. Negative 9 minus 4, that's negative 13. Alright. Question B. It says determine A inverse. Alright, so we now want to find A inverse. It's all about our formula. Do you remember the formula for A inverse? Yes, we should. The formula for A inverse, 1 over the determinant. Right? So 1 over the determinant, and then we are going to multiply that by the adjoint. And we're going to multiply that by the adjoint. So it is 1 over, what's my determinant? Negative 13. So 1 over negative 13, and then you multiply that by the adjoint. What's my adjoint here? I will interchange the leading, so that's negative 3. This is positive 3. Change the signs of the non-leading, that becomes negative 2. That also becomes negative 2. Alright. Now question C. Using A inverse. So using A inverse, solve the simultaneous equation that they have given me right there. So basically when they say to solve, they just mean that we're supposed to figure out what the x and the y are. Remember I showed you the formula, or I gave you the formula that we will use now to work out that part of it. So once we find the determinant, once we find the adjoint, if they are now asking us something about the inverse, remember you combine them together. And then if they want you to solve a simultaneous equation, you have to utilize your inverse as well. So using A inverse, solve the simultaneous equations. So remember now, if we want to figure out what the variables are, I am going to multiply the A inverse by B. Alright, so I'm going to multiply the A inverse by B. So that's equal to, so the matrix X is simply going to be X and Y, my two variables that I'm using. The matrix A now, so A inverse is 1 over, so the actual inverse that you got, so 1 over negative 13, and then we now multiply that by the adjoint, negative 3, negative 2, negative 2, positive 3. Alright, then I now need to multiply this by B. What is B? B are the answers. What are the answers that I had here? What are the answers that we had here? The answers there are 1 and 5. So we put 1 and 5 inside of here. Alright, so XY. XY equals 1 over negative 13 here now. So leave the fraction for last, please. Ooh, whoa, whoa, whoa. Whose mic is that? Mr. Duffus, sir. Mic is killing us, please. Alright, so leave the fraction for last. I need to multiply the matrices that I am given right there first. So row by column. So row by column. Negative 3 times 1, negative 3 plus negative 2 times 5, that is negative 10. Next row, negative 2 times 1, negative 2 plus 3 times 5, 15. So X, Y, geez, that is definitely not a good looking X right there. So XY equals, that's now 1 over negative 13, and I multiply it by the answers that I get inside the bracket. So negative 3 times negative 10, negative 13. Negative 2 times negative 2 plus 15, that is 13. So negative 3 plus negative 10, negative 13. Negative 2 plus 15, positive 13. And remember what I told you guys here about getting the answer now? Simply divide each number by whatever the denominator is. So negative 13 divided by negative 13, that gives me 1. 13 divided by negative 13, that gives me negative 1. So that means X is 1, Y is negative 1. Let me check that. So if X is 1 and Y is negative 1, 3X is going to give me 3. Then plus negative 2, that's going to give me 1. Right? So 3 plus negative 2, that's going to give me 1. 2x minus 3y. 2 times x, so 2 times 1, that gives me 2. Minus 3 times 1, no, minus 3 times negative 1, that gives me negative 3. I have to add those together, and that is how we would end up with 5. So that is how we gonna end up with 5. Alright, people, we're in the nitty-gritty here now. In the nitty-gritty, we're going to be finished soon, because I said here now, it looks like I really need to change from flow. Really looks like I need to change from flow here. Because I tell you, man, this is causing a problem, unnecessary time that I have to be wasting. Alright, let's do this next practice question here. So given the equations, write the equation in matrix form. That's the first thing. So step A, write the equation in matrix form. Remember, matrix form means AX equals B. Remember, A always represents the coefficients. If you don't see a number, the number is 1. So it's 1, negative 1. 3, 2 times X. What is X here? X will always represent the variables, the letters. Those are X and Y. And then that's equal to B. What is B? B is the answer. So that's 5 and negative 5. That's the first thing. The second thing here, determine the inverse of the matrix. Even if they did not tell me that, we should know that we have to find that once we're trying to solve a simultaneous. So we have to find the inverse. The inverse, 1 over the determinant, and then you multiply that by the adjoint. One over, so A determinant of A, leading diagonal, that's 2 times 1, 2, minus non-leading diagonal, negative 1 times 2, negative 3. Right? Make sure you keep that in mind. Then what is my adjoint going to be? The 2 and the 1s, they interchange. Negative 1 becomes positive, positive 3 becomes negative. And then you know 2 plus 3, that's going to give me 5. So it's 1/5 of 2, 1, negative 3, 1. Right, so again, leave the fraction on the outside. Then it now says, hence solve the equations. So hence solve the equations, that means I'm trying to figure out X. What is X here now? X is A inverse multiplied by B. So A inverse multiplied by B. So X, which is XY, equals, so A inverse, you know A inverse and all that? Oh, where's my A inverse again? Oh, A inverse 1 over 5. It's already there. 2, 1, negative 3, 1. Then times B, 5 and negative 5. So we need to just work this out now. X, Y, that's 1/5 of 2 times 5, 10, plus 1 times negative 5, negative 5, then negative 3 times 5, negative 15, plus 1 times negative 5, negative 5. And then the final answer here, no, well, not the final one yet. We need to add these things first before I work it out. So 10 plus negative 5 is 5. Negative 5 minus 5 is negative 20. And then again, as I was trying to say earlier now, to get the final answer, we divide by the denominator. So 5 into 5, that's 1. Right, so 5 into 5, that's 1. And then negative 20 into 5 into negative 20, sorry, that's negative 4. And that's a lot of work. And so all of these questions, all of these type of questions, they will give you a little bit of work to do. They always require a good amount of pages there. There we have that and the example that I gave. So that's those right there and the examples that I gave. All of these things right here. Alright, my people, so now these 3 remaining questions are just 3 questions based on anything and any of the things that we have done so far. Alright, so any of the things that we have done so far, doesn't matter. The first one here, the matrix A equals 1, 0, 3, 2, and B equals negative 3, 2, 1, 1, 4, 6. The first thing, determine A prime, the inverse of A. Second thing, show that A inverse times A is equal to I. I is the identity matrix. Step 3, determine the matrix A squared. Then step 4, explain why the matrix product AB is not possible. Step 5, without calculating, state the order of BA. So final question. That's a good one to close off with right there, even though this one doesn't have any of the simultaneous in it. Right? No? But we can do those on these. So good question to close off with here. Alright, let us go. Let us see if any of you will be able to get this or get these. So question 1, determine the inverse of A. Right, and that should be pretty simple. From we see that we know exactly what we need to do to figure out the inverse. Right, so remember A inverse equals 1 over the determinant of A, and then you multiply that by the adjoint. So 1 over, what's the determinant of A? So negative 1 times 2 is negative 2 minus 0 times 3 is 0. So negative 2 minus 0 is simply negative 2. So negative 1 times 2, negative 2 minus 0 times 3 is 0. Alright. Adjoint. What's the adjoint now? Switch the 2 and the negative 1. Change the signs of the others, but obviously you can't change the sign of 0. It is simply just 0. So that's what my inverse is. Next. So you can only get this question if the previous one was correct. So show that A inverse times A is equal to I, which is the identity matrix. In matrix, when we're talking about the matrix I, or when we're talking about the identity matrix, this is what we're talking about. A matrix that says 1, 0, 0, 1. So that's the identity matrix. Alright, so what is A inverse? So that's 1 over negative 2 times 3, 0, negative 3, negative 1. 1 over negative 2 times 3, 0, negative 3, negative 1. 1 over negative 2 times 0, negative 3, negative 1. 1 over negative 2 times 0, negative 3, negative 1. 1 over negative 2 times 0, negative 3, negative 1. 1 over negative 2 times 0, negative 3, negative 1. 1 over negative 2 times 0, negative 3, negative 1. 1 over negative 2 times 0, negative 3, negative 1. 1 over negative 2 times 0, negative 3, negative 1. 1 over negative 2 times 0, negative 3, negative 1. 1 over negative 2 times 0, negative 3, negative 1. 1 over negative 2 times 0, negative 3, negative 1. 1 over negative 2 times 0, negative 3, negative 1. 1 over negative 2 times 0, negative 3, negative 1. 1 over negative 2 times 0, negative 3, negative 1. 1 over negative 2 times 0, negative 3, negative 1. 1 over negative 2 and I'm supposed to multiply this by the original a, negative 1, 0, 3, 2. So 3, 0, negative 3, negative, oh, this is not 3, this is 2, so 2, 0. Alright. So, what's that going to give to me here now? So this is equal to negative a half of. So, let's work this out now. 2 times negative 1. So 2 times negative 1, that gives me negative 2. Plus 0 times 3 is 0. Then let's go. 2 times 0 is 0. Plus 2 times 2 is 4. Next, negative 3 times negative 1 is 3. Plus negative 1 times 3 is negative 3. Then negative 3 times 0 is 0. Plus negative 1 times 2 is negative 2. That is it, yeah. Adjoint is 0, negative 6, that's 2. And then negative 1. 0. Oh, how did I get 4? How did I get 4? 2 times that 0. How did I get 4 right here? Alright, so how did I get 4 right here? I don't even remember. Where is the duster? There's no duster. Alright, so 2 times 0 is 0, plus 0 times 2 is 0. This is negative 2 right here. So negative 2 plus 0, negative 2, then 0, then 3 plus negative 3, 0, then 0 plus negative 2, negative 2. Alright, remember now what you do, multiply each number by the denominator, divide each number by the denominator. Negative 2 divided by negative 2, 1. 0 divided by anything, 0, 0 divided by anything. Then negative 2 divided by negative 2, that is 1. And as I said, you're supposed to get back the identity matrix, which as I put it on the screen, 1, 0, 0, 1. You're supposed to get that back. And the identity matrix is a matrix. It basically represents the number 1. And we know about 1 and multiplication. Anything you multiply by 1, you get the same thing. So any matrix multiplied by the identity matrix is equal to the original matrix. Alright. Question 3. Determine the matrix A squared. So determine the matrix A squared. So the first thing here is A, negative 1, 0, 3, 2. So negative 1, 0, 3, 2. Right numbers. Negative 1, 0, 3, 2. Alright, what do we need in now? It says determine A square. What does A square mean? How would you approach that question? Stevie, we need to try a lot to think it out. How would you approach that question? Remember, when you square something, what are you doing? That's the key thing to remember. Right? When you square something, what are you doing? Right, so that's right. So once you square something, you multiply it by itself. So if any of you ever look at me, so if any of you ever look at me, is Zoom working? Yes. So if any of you ever look at me and tell me, say we're going to square the numbers on the inside, that is not right. So you can't just square the negative 1 and square the 0 and square the 3 and square the 2. No. So when you square something, right, when you square something, what you're doing is actually multiplying that thing by itself. So negative 1, 0, 3, 2. And what am I supposed to do here? Multiply it by itself, which is negative 1, 0, 3, 2. So multiply that normally like how we have multiplied all of those other stuff. So that's a 2 by 2 and a 2 by 2. And from you see that you should understand that these can be multiplied. So let's go. So row by column. First by first, that's 1 plus 0 times 3, that's 0. Let's go again. Row by column. First times first, negative 1 times 0, that's 0. Second times second, 0 times 2, that is 0. Next, row by column. So 3 times negative 1, that's negative 3, plus 2 times 3, that's 6. Then let's go again, row by column. 3 times 0, that's 0, plus 2 times 2, that's 4. So 1, 0, 3, 4. That's what it means to multiply something by itself. That's how you square a matrix. So that's how you square a matrix. So final 2 questions, and these are pretty simple. You don't actually need to work out anything. It says explain why the matrix product AB is not possible. AB, alright. If you look at A is a 2 by 2. And if you look at B is a 3 by 2. So why can't they be multiplied? And remember, when them ask you that, do not say because the two inside numbers are not the same. They are not gonna, well, they might mark that, but they're not really supposed to accept that. Alright? If they want to know why two matrices cannot be multiplied, if you have to answer the actual question for that. So what I showed you was just the trick. But if you have to answer the actual question, then you tell them that the columns, the number of columns in the second one is not equal to the number of columns in the first is not equal to the number of rows in the second. Final question. It then says, without calculating, state the order of BA. So without calculating, BA means B have to come first. B is a 3 by 2. A has to come second. A is a 2 by 2. They can be multiplied. That's why they're asking us about the order of the answer, because they can be multiplied. The order of the answer will always be what's on the outside. So that's 3 by 2. So that's a 3 by 2. And good night, my people. That is it for us. Well, before you leave, I have a couple questions on the screen I can show you to just screenshot that and try those. So I have 2 more past paper questions. But as far as what I want to do with you guys tonight, that is it. Alright, so thank you guys for being here. Let us look on the first question while I say what I am saying. Alright, so this is the first one here. You can screenshot this. This is another past paper question you can do for your practice. So you can screenshot that for me, please. Right, so you should have that screenshot right now. And then this is the final question here. This is the final question here. So again, another question that you can screenshot and try that as your extra practice. Alright, so thank you guys for being here. I really appreciate it. Right, please tell your friends. This is gonna be every Thursday night until the exam. I will try to see if I will try to see if I can sort out some digital play by next week or so, because I really and truly can't really bother with the way how this internet has been up and down, basically up and down. Alright, so enjoy the rest of your weekend, the rest of your day, the rest of your night. I will see you guys on Wednesday for the regular class, and then I'll see you online or on YouTube on Thursday. Alright guys, so good night. Enjoy the rest of your night. For the students who are here online as well, thank you guys. I appreciate everything. Please do like and subscribe before you leave. So bye bye, good night, and see you guys next week.